Hello everybody, welcome. How are we doing? Apologies, been a little bit late, just been got some guests over. Rightio. So last stream was pretty great. We got a couple of shaders working out of the sort of I think it's like 6 or maybe 7 shaders for the LOD and cluster construction work that we're working on, right? But those couple of shaders, they don't do anything, they just reset some arrays at the moment. So we give that a run. Here's the old renderer. But as you see, there's a couple of shaders in here. There's the volume constructor resets. This resets all the state for the constructor. There's one that starts the first frame, where we have a persistent piece of memory, where it basically keeps an array of a free list for the spheres, so we can allocate spheres. So that's pretty cool. But the next one we're going to work on is this lovely. So it's a shader that builds the initial cluster tree with all the leaf nodes and the leaf spheres placed down. We launch one of these shaders for every single LOD. So we start at LOD 0 and we go all the way down, all the way up to the higher level of details. And so something this doesn't do is it doesn't generate the lower level of detail, and it doesn't simplify the tree. And it also doesn't clear any nodes that are kind of empty and hanging on the end or anything like that. So another thing to note as well is this is because because the amount of space we need to build is basically what's the word? We have to build a very rough a rough version which is not simplified. So we basically have a nice block of memory where we just do all the building in, and it's allocate to the maximum size for a single volume. And then we'll do all the building and simplifying in there, and then we can do a nice neat copy out to a persistent piece of memory. So yeah. Hey there, Clappy, how's it going? Okay, I'm not muted. Excellent. That'd have been annoying. Righty-o, awesome. So what we want to do now is, so I thought off stream, there's a way for me to save some memory. So I think I might just start there, and then we'll double check over the shader. Oh, sorry, we'll get the CPU side code all hooked up. Make sure that's all good, and then we'll double check over the shader before we run anything. So there's basically a volume cluster node. So this guy, so for a sphere, we have 250 cubed of those, which is a lot. And for a cluster node, because there are 2 by 2 by 2 of spheres, we have 125 cubed of these, at most in a volume. This is before simplification. So as soon as you simplify it, we only keep the ones that go around the edge of a model. So it's fine. But it's just when we're building it, that's how much space we're going to use. So ideally we want to minimize the amount of the size of these guys. And this is a lot because it's 4 times 8 bytes, right? So that's 32 bytes. And if you're doing that per node, it gets into the megabytes for a full volume's worth. So unfortunately, we have to keep this the way it is because it's just the best method. But we don't need these past the shader we're about to try and test, which builds the initial tree. Because we only need to build it because wait, I'm curious, do we need them at all? Oh, we need it in the refine. Because the refine needs to be able to look at their children. Yes, we need them in build phase. Um, we need them when we build. But maybe... So this one starts... unfortunately, the way this one works is it has to traverse down from the top, from the root node, and find the cluster it's trying to build. And while it's going down there, it will... find the cluster it's referring to or something that we need to focus on. So... Like, could you start the root nodes? Because that's when it's better. Sorry, at the leaf nodes, I meant. Because if you can start the leaf nodes, then you might only need a parent index. Wait a minute, let's just double check this. I think it's best to see if we can get it, if we need it for the refine. Here it is, the refine. So the refine starts at the leaf nodes and then it traverses up the tree from the leaf nodes, which is best if you have like tons of threads, right? So each thread gets, we have one thread per child basically. And we check the children to see if we need to create the lower LOD sphere. Yeah. Okay, I don't think we can get rid of it, and that's fine. So we can't get rid of these child node indices, but we don't need them after we've built a volume. So what we're going to do is we're going to delete them here, and then they don't belong with a node. So the beautiful thing is then, we can just have another buffer on the side, which is specific for storing these children indices, right? Volume cluster node children node indices. It's a very big name, it's terrible. Cluster children node indices. Yeah, I think maybe I should replace this name with volume constructor cluster nodes buffer ID. Just swap it around the other way. Just makes better sense, I think. So when we make this new buffer here, we'll move this name at the start. Keep it consistent. So these are specific for the volume constructor. Right. So the great thing is about this one, children node indices. Okay. So how many of these do we actually need, right? So when you've got a, like the only ones that have child nodes are, so if the biggest volume is 250 cubed, right? Filled with spheres. The leaf cluster, right, is a 2 by 2 by 2 of spheres, meaning that's 125 cubed, right? At the highest LOD, right? So that means these ones don't need child indices, right? So then it would be half of that. You know, I should just be working with it might be better to working with power of two numbers, because then they actually half properly, right? You don't get like half numbers or anything dumb like that. Yeah, that might be something to think about, because it's just going to truncate. Oh, we shall remember that. But yeah, what we need is where's the header where we did the that's right here. Good. I think this is the number here. Max non-leaf nodes. Yeah, that's it. So all the non-leaf nodes, these lovelies, all have the possibility of having children, right? The leaf nodes can't have children. So, and that would be of S32. Amazing. So now we've got this lovely buffer. We just got to get it passed in to the shaders, right? So yeah, part of me's thinking I need to rename these a bit, but it's okay. We can just carry on. No. Yeah, I think these shader names, you get a bit of a different name. I might heavily shorten it. We'll see. So we need a new buffer and it's basically S32's read write, volume cluster children. So the way you index into this buffer is you basically just take the node index and you simply just multiply that by 8, right? The number of children, and that's where you start in the array. It's pretty basic. Wait, we didn't even times this by 8. Max. No. Cluster children count. Yeah, so it's the number of leaf nodes times by the number of children times by the size of the indices. Fantastic. So now we've got this guy. We have to make sure this gets set in the CPU code. Volume constructor children node indices buffer ID. So this is the push constants, and then we need to make sure we do the synchronization. Bearing in mind the synchronization needs to happen every iteration of this loop. Yeah, I'll be happy if... where is it? They're the right way around. Okay. We'll get back to this in a minute and make sure this is all good. But let's go throughout the shader code and swap it out to use this new buffer instead of storing it in the nodes directly now. So in that shader, it used to be called like children node indices, right? So this now, you just want to be using BC volume cluster children node indices, this multiplied by cluster children count, right? Wait, no, that's children index. Sorry, wrong one. That should be plus at the end. So what's the node? What node are we on? Yeah, so the absolute cluster node index, because yeah, perfect. Because these node indices are actually signed. Negative means they're a leaf node. Positive means they're a non-leaf node. So, which is pretty sweet. So that's how we index. Wait, no, that's not. What are you doing? Get out of there. That's how we index for the children now. Yeah, it should be right. So let's take this with us and keep going. So this one says like, oh, I've allocated a new node, and then it's going to clear all of the children. Wait, do we get a node per thread? What are we doing? Oh yeah, of course we do. Of course we do. So this one's going to... Why does it set it to U32? That doesn't make any sense anymore since they're signed. What should it be clearing it to? You can clear it to 0 since it's a relative. Yeah, but then you get No, we do a big number still. We'll do S32 max. That'll just pop it out of the array, and that's fine. Will it pop out of the array though? Because it can cause it to wrap and to be an unsigned. And then we'll think it's a leaf node. If we make it 0, then it means that it's pointing to itself, which can cause some infinite loops. So you just have to be careful when you're reading it, I think, but we'll be looking at all those cases. Yeah, I think we'll give that a go. So anyway, is it the right node index? ABS node index, child index, right? Gotta be extra careful there. Hey, not so red. How's it going? Yeah, doing good, man. Doing good. Just been busy at work, and yeah, had a pretty cool day today actually. Managed to fix something which I wrote a few months ago, which wasn't that great, but I managed to come back at it again. And well, to be fair, it is actually a great thing that I wrote before, but I did at an aspect of it which ruined the code. So I managed to go back in and fix it up. So, and that's all been revived, and it's awesome. So I'm super happy with all that done. But yeah, just the usual. Just been working hard, chilling with the family, working out. You know, how's things for you? How's the New Year treating yourself? Um, right. So we create a new node. Yeah. We could zero the whole piece of memory, which means you never have to do this. And then you'd be zeroing a whole piece of memory, which could potentially be quite, well, maybe it's not big. Anyway, let's just carry on. Well, I'll put that in a much better place. Okay, let's keep going. So this is in the refine. Yes. So the refine needs to know. What does it need to know? Right. So another case is it could be 0, and this is the safety check. Yeah, that could work. So what I want to do is read that child node index. Right. So we read from the buffer. Where's mine? How do I get this node? This one, good. Okay, so we reach inside the different buffer and get the children out now. And here we're just gonna do the safety check. And you know, it could be pointing to itself. That's another one where that's an invalid state. So I'm glad we got that in there now. And this one wants to reach inside the parent node. What is that for? Make persistent. So for make persistent, we don't need this at all anymore. Because it's not persistent information. We don't need to keep a list of child indices around anymore. So this can just go. So this used to reach into the parent node. That has not been made persistent yet. It will be made in one of the next iterations. And overwrite the child reference to our own node, right? But we don't need that anymore since we don't have child references because we just removed all those. Legendary. And there we go. So I think the cluster constructor reset might need it. Yeah, you know what, we're going to zero this buffer. And then it just saves doing all that silly stuff, you know? Saves doing this. So before we launch, we've got a zero thing we can just use, right? Cluster reset, all good. I think it's like GPU command buffer 0. And 0 is the whole buffer. Pretty sweet. Chaos Pill, how's the custom C compiler work now usage? Pretty good. Last stream we had one of the first bugs in a while. Turns out it was something to do, like the bug was in SpearV. You can't basically if it's not a structure or an array, any other type in the system you can't have duplicates of, right? So we had a function type which is being duplicated. So the function prototype type was being duplicated, and it took a bit to figure out, but it was something to do with the fact I wasn't I didn't take my high level data types that are in the C sort of language, right? Like int, long, short, and my resource types. And I wasn't bringing those down into like the most lowered form, which would be like proper sized integers. And when I was deduplicating it, it was obviously bringing up duplicates, which lowered down into the same form. But yeah, it's been the compiler's been great other than that bug. I think also the bit fields might have broken as well. Well, storing bit fields into a buffer broke. So I decided to just not use bit fields at the moment. But you know, we've got some quite complex shaders and they seem to be running fine. Well, we've written some complex ones down here, like the ray tracing ones. They've all been running fine. About to get some more complex shaders up and running. So yeah, it's going good. Hope enjoying it. I'm doing alright. I've been sick. I only worked one day. Oh no. I'll get back into office tomorrow. Cool. I hope I don't catch a cold again since I'm not fully recovered yet. Yeah. Yeah. There's been something that's been going about, isn't it? Like some COVID or cold. There's been a few things going about. Yeah, I hope you feel good soon though. Yeah. See, it's kind of interesting that I sort of work from home, so when I get ill, if I'm not like if my brain still works, I still just sit at the desk and work. But you know, if you was in the office, you would like not go in because you don't want to like spread your germs to everyone else, which is an interesting thing. But I think I've taken like one sick day off because I literally just couldn't work. I was just so ill. Yeah, it's one of the weird things about working from home. I just want to go and work still. This is weird. But yeah, I hope you recover soon. It sounds pretty nasty. My my brother's partner, um she got COVID over Christmas. She was just isolated, unfortunately. But she managed to come out towards the end. But it's just one of them. Really sucky. Yeah, so just gonna make sure it's all compiling. What's it complaining about? Oh, okay. So this refine LOD also needs that array, obviously, right? And this probably is read only. Reading those indices. Awesome. Please rework my lexical scope system. The watch job I have now certainly does not work. Yeah, I know what you mean. Like, compilers are one of those projects where when you don't understand what compiler is, it just feels like this mystical black box thing, and then you sort of like start getting the idea of it, and you really just have to write a few to sort of understand how to do it well. Yeah, but it's fine. Don't worry. It's going to be pretty botch. I got function pointers and arguments working in x86, x64 Linux. Nice. Did you do the whole arguments that are bigger than the register size? Yeah, I was thinking. What happens for structures, right? Or have you got the structures right? You know, because if you have two integer fields, right, in a structure, you got that sorted out? Because that works in a very specific way. Like, I forget what it is. I think sometimes it's passed by pointer. Depends on the calling convention, right? Sometimes each one of these gets a register. Yeah, it really depends on the calling convention. But I can call functions from C now. That's cool. Woohoo! Just got to make sure it doesn't pass in much. Yeah. So all you really do is pass in a pointer somewhere. You know, job's good. The next approach at the lexical scope will use a rooted node tree to represent the lexical scopes. Ah. Yeah, typically you just have like a very generic tree. Like, are you talking about like scope blocks and stuff in functions and that? Elspeth. Yeah, they're pretty easy to do. If I just bring up HCC for a bit, I think I can just explain it. Help you out there. So basically, you just have an expression. Yeah, so you just have an expression, right? And an expression is like all of your stuff within inside of a function, pretty much. And so got statement block, right? And that's your lexical scope thing you're talking about. And basically, it's just like, so this thing is like, it's got an expression type, and it's just a union. And then you've got, where's the block one? Here we go, statement block. So you just have a pointer to the first statement and the last statement maybe, and you just link list to the next statements. So these expressions have next pointers in them. These goes to the next statement. So you just do something like that. Just a linked list of, and it just basically becomes a tree, doesn't it? And you can mix it with all the other stuff. This way you can have like return from blocks and stuff if you want to do all that crap. In system 5, if the argument is less than 64, you can pass it a register, if I remember correctly. Right. If it's 128-bit, you pass it to 64 registers. And after that, you got to start spilling. Well, not spilling. You got to start, you put it onto the stack, isn't it? Maybe it's called spilling. Awesome. Right, we're in business. So, now's the time to make sure this is all good. Yeah, so I think we, I don't know why I was doing it this way. Oh, it's right in front of my face. Oh, no, it's not. All right, there we go. Yeah, so I was kind of like thinking about kind of filling out these structures and just using these rather than hard coding. Well, still hard coding it, but using the structures as well. So this is what's going to be saved on disk. So with the grid dimensions, like well, if you have the grid dimensions stored on disk and the max LOD, like how useful is that really while you're building? Maybe we just compute that when we do the final copy, right? So maybe these things, well, it might be useful to know like this thing is this size at the highest LOD. Very wrong though, I didn't read much about it. Fair play. Yeah, it's got to write a bunch of tests. And yeah. Some of those documents are really difficult to read. You just have to see what the other compilers all have done and have agreed on, basically. I'm sure there's been tons of like... It's the same with the C standard. It's very difficult to know exactly what they mean half the time. So this information could be useful. Well, it's pretty easy to get right, these grid terms. Right, then max LOD. Okay, so this is what I was trying to think about end of last stream. So the basic idea is that we've got a nice lovely little like volume. We can paint spheres down at the highest level of detail, right, which is 8. And then it goes all the way down to 0 or something, or 7 goes all the way down to 0, something like that. There's 8 level of details. Then you can also paint a specific LOD. You could say, you know, I want to paint something that's bigger, and it has to slot onto the grid. You sort of just paint down higher LODs as well. And when you paint over a higher LOD, it gets rid of anything that's in that area. It just deletes it. Okay. So there's a couple of things, right? When you compute your tree, your LOD cluster tree, you might have painted down at a lower LOD, but never painted the highest LOD, right? The system's going to go over and run it over all the LODs. I guess it's not a big waste. I guess it's not that much of a waste. It might just stop. It might just start them up, and they'll just sort of go down the tree, and they'll stop there basically, I think. Yeah, it won't be too much of a big waste. Like we could basically store the max LOD. Yeah, maybe we'll just store the max LOD. We'll get it to just not trigger them. Surprisingly, Microsoft had good documentation on their Win64 calling convention. Way better than System 5 ABI manual. Yeah. Yeah, I think Microsoft has a few of them. They have a few calling conventions, or they have like 3, or maybe more. They're like CDAC call, yeah, standard call, and fast call. Probably another one. But also, there's like probably they've got quite good documentation on the actual COF, the PE COF format, the executable format. That's probably quite decent as well, because it's just been there since the beginning of time, you know. So you have these max LODs. We can keep that so it sort of saves us some space or whatever. Sorry, so it saves us some time making these things, because that could be quite precious, right? Time that we could have lost. Since it eats into the frame budget, you might as well try and avoid as much as you can, right? So there's also like a min level of detail. Like you'll go up from the bottom of the tree and try and simplify it. Where if there's a cluster that's completely surrounded by other clusters, you're going to get rid of that cluster. Well, not get rid of it, you'll join it with the ones around it, basically. Yeah, sorry. You'll get rid of that cluster of 2 by 2 by 2, and it will, but instead there'll be a 1 lower levels of detail sphere in the parent node. So then you might get to a point where the tree doesn't simplify anymore, and I guess it's not that bad keeping the nodes around, but we could have like excuse me. But basically, if the tree doesn't simplify anymore, we might as well just delete that parent node. And you just keep deleting the parent nodes until you reach something which has, like, only keep the nodes which actually have volume, have a sphere on them, and that way we can just have more volumes that exist in memory. Yeah, that can work. So we can do something like that. So when we do the refines, I got to do that. Okay. There's also another thing as well. Wait, is that it? No, that's it. So grid dims, that's how many um, I don't know how this is useful. So what are we going to use it for? Yeah, it's needed in the shader. So we need to get this right. Um, so what are we doing? Oh, okay. Radio. Okay, so max LOD will be 0. Let's do that for now. Let's just say, so we're 250, right? Let's do 250, 250, 250. Let's just do 250 cubed. So it's comprised of these edit things. Now this is kind of read on yeah, right. We're gonna have to bit pack this. Because one, this is serialized to disk. Two, uh, if we, well, yeah, we could technically read it. You know what? It might work out just fine because we should be able to load it from shaders right now. Yeah, this will save us some time while we're just demoing it. To do convert to sort of okay, manually bit pack for obvious reasons. Right, so let's fill in all these things. So I want to get all these guys in. A material palette, material index as well. Alright. So let's start off as 0. We've already got a material palette set up. But you know, when we're rendering we'll do it. It's just basically like a color palette but with materials. That's all it is, nothing special. So these are encoded as fixed point. So I think I did past Henry, saving the day. So pack as fixed point. Isn't she lovely? .f. Okay. So what's the next thing? So yeah, how big are these things going to be, right? Well, They're the half dims, right? So it's 125. The volume's not declared. What? Right, max LOD, custom edits or whatever. Yeah, this should be serialized way better. Maybe we should just do something like, yeah, well, nah. Let's just pack them in like that. Okay, so when you dispatch this shader to build this lovely thing, so this is just going to basically do one ellipsoid paint, and it should cover the whole area. Well, yeah, it should cover the whole area. Maybe we should do a little bit smaller. Should we do half of that? We do. Yeah, let's do half of that. 62.5. Right. So where we do this lovely shader launch. Too many shaders, man. So we'll get our pointer to our volume or whatever, right? Which will come in from somewhere, right? And the upload code, it's probably already been uploaded. I don't know. But anyway, in it, we'll get this from somewhere. The volumes might be around in memory or they might not be. I don't know. That's a lot of dots. So we need to go up to max LOD plus 1, right? Because we want to, yeah, we need to loop over that one as well. So we're currently just going to do LOD 0. So we should only get one cluster of 2 by 2 by 2, and we should be able to see that in render.doc whenever we get this thing actually working. Now the thing we need to do is we're launching from low to high. We need to make sure that we take the volume. We need to dispatch correctly, basically, right? So you've got a cluster. Well, we're doing, so clusters are 2 by 2 by 2. Because we've got 32 threads per wave, we're doing 4 by 4 by 2, which means you fit, you'll fit 2 by 2 by 2s of clusters. Wait. Yeah, in the sorry, which means you'll fit a 2 by 2 by 1 of clusters, right? Um, so yeah, along the x-axis you have 2 clusters, on the y-axis you have 2 clusters, and 1 along the z. Is that right? Yeah, each thread gets a sphere. That's right. So we need to, based on like this information that we have here, this volume. You know, this actually fits in like a U8 now. Didn't realize that. It might not, because you've got, we might go up to 256. That might be right. So the lowest level of detail, like given these grid dimensions, see, maybe the grid dimensions is just not a good idea to keep around. Maybe we have it on the GP, we work it out on the GPU. Hmm. Yeah, maybe let's not care about these right now. Let's remove them. Can always bring them back. So the idea is we need to know how much to launch. Um, so the first LOD has 1, the next LOD has 2. Or does it? It's still 1. Yes, you need to do like, what is the... See, another problem is I'm not using power of 2 numbers for the highest. I'm saying 250. The reason is 250 because it gets to, 250 times 4 is 1, so it goes into a meter just fine. Um, so when you do, 250, you divide that by 2, 125. This one doesn't really divide by 2, right? So 62.5, and then 0.25, and then with this weird number, right? So we could... so yeah, you definitely have to round up when you divide, right? Um, when you're constructing the tree, right, so imagine that is LOD 7, 6, LOD 6, 5, 4, 3, 2, 1, 0. Is that right? So LOD 7, 6, 5, 4, 3, 2, 1, 0. Right, it's one out. It's supposed to be 9 on 1, right? 6, 5, 4, 3, 2, 1, 0. No, it does make sense, doesn't it? Okay, so how do I want to do this? Do I want to say like so I'm trying to work how do we so we're dispatching the lower LODs, but our kind of our biggest is I could just have an array of the numbers, right? And we just select them. So, for instance, we could do something like this. I'll show you a good idea this would be. But you would do like 250, 63. Um, 32, 16. So I guess it's just standard past there, right? 8. 4, yeah. Then 2. So LED 0, 1, 2, 3, 4, 5, 6, 7. Wait, where's 16? There we go. So the ones that end up being different are these ones. Other than a power of 2. So this number of this is not going to be good, is it? Maybe we just go back to power of 2 numbers because the problem is at the lower level of details, these didn't perfectly divide, which means you'll have some clusters of 2 by 2 by 2, which kind of will go further than the highest level of detail can. So if we just draw this out, this might be a LOD 5 or whatever, and then, but you've because it's been rounded up, it can technically Is that correct? Yeah. So then you might have the highest level of detail, which is like a lot smaller, and these guys have to stop here. But because like in the lower level of details, this this whole cluster, which works for this sphere, would have had to disappear, which works for these like 4 spheres here or whatever, would have had to have disappeared because it goes off the end. So we rounded it up, right? And because of that, these don't fit on. And if we just allowed the extra ones to go on, then it would go up to 256. Yeah, it's gonna look dodgy. It's gonna feel dodgy. So maybe we do 256 then. The only problem is that metric doesn't. Yeah, let's just, unless we have fake meters. Um, Maybe a meter is 1024. We just roll with that, you know. It would just be easier that way. Things just perfectly divide, or divide by 2, right? Yeah, we'll roll that way. So this means it becomes a lot more simple and know what to dispatch. So the problem is this shader does 4x4. Yeah, there's 2x1 clusters at a time. So we just need to get the number of clusters along a you have 1 cluster, then 2 clusters, and so on. So it's literally 1 shift left LOD. That's the number of clusters. So clusters along a dimension is this. Then you simply do divide roundup of this divided by 4, divided by 4, and the last one is divided by 2. So volume dims at LOD. Right, do we use that? Okay, so we do have a thing where we can stop it from going outside, maybe. Hi, I have a HTC related question. Hey, Spherical Cap. Do you apply any optimization passes during code gen? Is it worth it since the driver does some heavy lifting? So we don't really optimize much. There's some things which we could have done, but we don't do it. We can make the we could like if we were going to add pointer support, we probably would need inlining, so we could inline and figure out where the pointers point to, basically, and get their storage classes all sorted out and infer all of that information. So there's certain like optimizations which we could do, but we don't end up doing. But you're right. There's 2 levels of optimization which basically come for free when you write a shader compiler. Your SpearV opt. SpearV opt. This thing, we just call this like any other compiler does for Vulkan. And this will optimize the SpearV binary as much as it can with the information it has. And then you send this to the driver, and the driver lowers it even further to the hardware. and optimizes it using probably LLVM. So basically, you can write unoptimized code, and it's fine. We don't even need the dimensions here since you have the constructor LOD, but maybe... Yeah, you can work that out using the constructor LOD. So you basically just do one shift left. Volume dims at LOD. Awesome, no problem. Yeah, it's part of the reason why I did the project, right? Because it was so, basically very easy compiler to write. You don't have to worry about writing the lower level part. And I could have just used another compiler and hacked that way, but then I have to understand a complicated code base. So, and also, where's the fun in doing that? Right, so basically there, we do have to synchronize on the same stuff, so we'll put a barrier in between it. Excuse me. And voila. This is the launch code. So, yeah. This is only going to do LOD 0 for now. But we'll change the edit information above and, do better. So now what we're going to do is go into this code here. And we're going to double check everything, make sure it's all good, and then we'll get it running. Probably crash the computer, you know things go. But yeah, hopefully get this thing up and running and we can start seeing, playing with the edits and seeing the data in RenderDoc and see how it looks, right? Okay, I just need to go and fetch some more water because I'm out of drink here. And then we'll go through this shader and get it all going. BRB. Alright, welcome back everybody. Ta-da. Okay. I haven't said here what each thread does. Each wave is a 2 by 2 by 1 set of clusters. Each thread in a wave is a sphere within one of those clusters. Ta-da! Each wave 32, let's be obvious about it. Alright. So 32 threads. Kabam. Right. Right. So they get the cluster index, sphere index, all good. So what it is to go from the construct LOD to the highest LOD. So in our case, this would be 0, as this would be basically 8. Is that 8? Yeah. 8 take away 1, so 7. Take away 0. So in order to get to there, we need to the highest LOD. We need to add 7. So coordinate the highest LOD. Shift left. LOD sphere radius, which would be 1. Shift left 7. Well, why do we use this? Oh, of course. Right. LOD sphere radius. Oh, yeah, at the highest LOD. So this would be 1 shift left. Yeah, 7. So that'd be 128. Yeah, because there's 428. Wait a minute. But why do we half it? Right. Because it'd be 1 shift left 7, which gets you 128. And that is already... Something's off. Hey, Cat Pain, how's it going? Hope you're doing well, hero. Train keeps chugging along. Yeah, man. Gotta get stuff done, you know. The only way to finish stuff is keep going, especially this complex stuff. But it'll soon be done, and then we can just smile, you know, and move on to the next thing. But to be fair, there's actually still quite a lot to do. But it's all right, one piece at a time. But how's the week going for you? Yes, this is a bit concerning. The fact So for the coordinate, so I think we've gone off by one error. So this would just be 0 on the first one. Um, so do we have 8 LODs or do we have 9? Like, because that's bit 9, right? It's bit 8. Yeah, bit 0. That's the ninth bit. Um, yeah, so you shift right 8 to get there, right, obviously. So, or shift left. So, is that the right shift amount that we need? Where else do we use this? Do we use it here? Or just in these two places? Fair play. But these are probably used elsewhere. So when you have a coordinate at the construct LOD, this will just be like basically 0 or 1, I reckon. Um, um, so when you go to the highest level of detail, the first one is a 2 by 2 by 2. Right, that's where it makes sense, doesn't it? Right. This is probably wrong. So that's correct. Now this is correct. So it's one shift left 7, which get you 128. This volume dim at LOD. So it'll be one shift left 0. I think you should start at 2. Right, so construct to be 0. Yeah, that's right, isn't it? 0 all the way to 7, and 2 shift left 7 would be 2, 5, 6. Okay. So initialize LDS. This all looks pretty straightforward. Nothing wrong with that. So we traverse down the octree. So and we start from the root node. And the reason why is because we want to build a tree. Yeah. I'm trying to think because we did build a that BVH tree when that BVH construct. We did a BVH before. Calc bounds this guy. We built this from the bottom up. How did we do it again? How did it select the right node? Curious. Oh, it was all implicit. It was an implicit tree, wasn't it? Yeah. There's surely multiple things linked to the same parent. So I wonder how you do that another way. Yeah, it's not necessarily a big deal. Because either way you gotta traverse the tree. Right, let's keep rolling with this one. Right, so traversed down the octree, find the cluster this thread owns 1/8 of, and see if the sphere or child node should be placed. So we get the midpoint cursor. This has been set up by now, right? It got set up in this reset shader, which we've already done. Get the min and max. Yep, that makes sense. Yep, that'll work. Do some safety check. Oh crap, did we? No, it's fine, that's fine. Fine. What even is this? Node index. Alright, that's the future one to look at. It's not this shit. Well, okay. Let's just quickly look at it. Midpoint. Negative that number. Refined node even has the same problem. Make persistent also has the same problem. Right, back to where we were. Okay, so we go down the tree from 0. So on the first one, we're gonna skip this whole thing, but let's just double check it anyway, because we'll instantly go to the next LOD after we get the first one working. So you basically get your cluster node index, do some safe bounds check. If it goes out of bounds, we set the edits to 0 and just basically kill the shader. But we need to make sure every thread still runs until the end for reasons. So we calculate the absolute index, fish that boy out, nice and safe, otherwise the GPU is going to crash. LOD diff going towards the cluster LOD from the current LOD. Yeah, this is guaranteed to be greater, so that's fine. Coordinate in LOD, shift right. Yep, but the LOD diff, excellent, so that shrinks it down. Rounds it down as well, truncate. Calculate the child index. Child index in where? Sorry. Yeah. Yeah, see which sphere. Yep, it's all fine. We'll check if the sphere exists. Now this is some lovely long code. We'll just simply correct this one. Make that a bit easier to read. So basically what we're saying is, you know, maybe we shouldn't join that up onto the line like that. It's not that nice. So if we have spheres and a sphere exists in that node at that child index, sphere exists not equal to 0. What do you want? LOD does that for me. So stop here as the leaf node placed at this lower LOD. So painting any further does not make any sense. Right, so I've already painted a sphere here, so yeah, stop early, that's fine. This one is saying stop here as when this node was constructed, the child node was deleted by an edit operation, so we don't need to process this cluster or its descendants. So that's the wrong way around. Right. So what we're saying here is if the child does not exist, don't, because we're going to traverse to it right here. So now we know the child exists, we fish out the index in the other buffer using our cluster index multiplied by 8 plus the child index, which is 0 to 7 inclusively, get the index, put it into there, and go round again for round 2. So we keep going until we reach our LOD, and that looks all good to me. So we just traverse down the octree basically. So now we get to do the whole sort of like, we're at the octree node, and we've got a thread which targets a specific sphere, and we're essentially just going over all of the operations and seeing if it actually colors it in. So right, so we get our absolute cluster index, and so we go over all the edit operations one by one. We unpack the fixed point 10.6 integers into floating point. We unpack the quaternion. What is that doing there? Oh yeah, great. Okay, so we'll work it out here proper. No biggie. So here we're trying to see if we're basically, if this edit affects our sphere, this threaded targeting. So so we add the grid cell half dimensions to the center coordinate in the middle of the cell. Yeah, in the middle of the cell, and extend the half dim so we can test a single point to see if the shape partially overlaps the grid cell. But we want to do that. We only want this conservative grid cell check. On target LOD, this is an old comment, isn't it? When we continue past the LOD, see if we fully overlap. Yeah, no, we see something more complicated. That goes now. Okay. Yeah, it's much better simple now. So we got our LOD sphere radius, which is 128. So that's the half dimensions of a cell in the octree. Oh, it was right to half it. Past me was on it. Why did I change that? Because we want that to be 62.5. Because that, with your cluster, yeah, 62.5. That's the radius of a sphere. Okay, excellent. So we add what am I doing here? Why is this thing at because it's U32. Okay. So convert those to floats, and then we add 62.5 to them. So we're working in the highest LOD space. And then we rotate it. Yeah, I'm not sure about this rotation, to be honest. We can have a play with that in a bit. Yeah, as we... This isn't the thing to test, but I have a feeling this is a bit wrong. Because you want to rotate around the local space of the ellipsoid. So I think that's a little bit off, not gonna lie. But we'll just carry on and assume it's true. So we're gonna add it to the half dims as well. Excellent. And then we just say, okay, if we're an ellipsoid or a cuboid, do the point in sort of or ABB check. Cool. And then if we're outside the shape, we continue and go to the next edit. Okay, so now this is where we do the painting operation code basically. So this whole shader runs at a particular LOD, and each edit can target any LOD. But if the LOD is less, if we're painting at one that's lower than one we're constructing, then we're essentially yeah, we remove the... Have a good night. Yeah, have a good night, Nusret. Appreciate it. You too. See you in the next one. Have a good good start to your weekend and a good end to your week. And I hope you feel good soon. Right, in a bit. Thank you. So this means that you're painting down a lower level of detail, so bigger sphere, and you're constructing the smaller spheres. So obviously you're not going to try and paint over like this is targeting a different LOD. So it's not. So the only thing it's going to do is be able to remove. So if a sphere exists, we shouldn't need that anymore. If a sphere exists, then we remove. Yeah, we do deal with that. Then we remove the sphere as the LED sphere is brushed over us. So we clear the fact that that one exists. Yep. And then we subtract from the shared LDS memory. We don't need a child node as the low LED is brushed over us. This will stop us making a child node any further, and it says that it is a leaf. Makes the current node a leaf. So this is what we jot down for the end of the shader, so we decide whether to allocate a node or not. Now if we're brushing down a high level of detail than we're currently constructing, and we construct from low to high, so this is the thing which will help us build the tree. So if a sphere exists at this current LOD, we remove it, right? And we say we're going to need a child node as this higher LOD is brushed over us. Now this is partly true. This should only be true if the edit op is equal to add, right? Because if the edit op is remove, like until you've added anything here, all the other operations are meaningless. I think there's another one where you can like paint down a material. That's just about it. So edit. So this is a leaf. So it continues to be a leaf. So it's only a leaf if we're specifically constructing the next LOD. So if that's I think I'll go with an if statement. Same as removed, right? It's the equivalent of just removing. Because if you just remove from the high LEDs. Yeah, okay. So this next else statement is like we're editing like where the LED that we're constructing at this dispatch is for the target edit LOD as well. It's the same. So this means that the add-in, like this is where we basically put down spheres now, because we're painting inside this sort of LOD. So we know we're inside the shape. So we'll go into here and we'll basically say, place down a sphere. We're new if we don't exist currently. We construct the volume sphere. It's a 0,1 offset. And the construct LOD is the material index that we're painting down. Also generate false, and it now exists. We then add if it is new to the count. And we don't need a child node here because this is a leaf sphere and it no longer is a leaf. Excellent. Then if we remove, isn't it just the same as the one above? This just feels like to me. Oh no, you're painting down. So you should remove any the fact that a child could be made. Yeah, so what you're saying is if it's less than. Yeah, remove should just always go into this thing here. Excellent. I've still got to do the other paint one, but we'll do that when we need it, right? So that's all of that. Now it's just these two final bits, and then we can start seeing how stuff goes. So we have spheres. First thread in the cluster of 2 by 2 by 2 will allocate us 8 contiguous spheres. So the first thread, this is why we need all the threads to keep running. So then we subtract from the stack count, get a slot, get the 3 indices basically from the end of the array. We pop off a 3 index. This would be an index where there's 8 slots afterwards. Nice. So then we can set up the array like so. Then we can read the array back out on all the other threads as well as the same one which did this. And get the start index. And then with that, we can copy all. So all 8 threads basically, which target the same node, will be copying the same cluster node. Will be copying into the same. They'll be copying into the same sphere array, if you will, right? Of 8 spheres, but it just does it all in one line, right? Because that's all different across every thread. That's the same across 8 threads, and it's reads from LDS and put. Yeah. Cool. Now we need to allocate a child node for one of the next dispatches that constructs at the next LOD up. We allocate a leaf node. Right, what is this? Because so that'll get you back 0. This will also get you back 0. Should be -1 take. Did I really get that wrong? I think I did. So let me just figure this one out. If you get 1, that's -1. That's your min. Yeah. So where's the next time we do an allocation? Here it's -1. This is it. We make it persistent. Right. Okay. I'm glad we fixed that problem. Yeah. So these start at 0. To get the absolute index, we construct the cluster node. So it's got a location. So from the current node times by 2 plus the offset. Yes. No spheres. It's got a parent of the current node. And good. No children at the moment. Then we copy the node into the child of the node index. Yep. Into the child indices for the node we've been doing sort of up here, basically. And then we set bit set in there as well. Right, that's looking good. Okay. What? No, I got compiler bug. What changes caused this to happen? Wow, we're still going. I have a feeling that it's the... I won't worry about it. I have a feeling it's to do with this. It's in the shared code. There's a pointer type in there, basically. And it's like, I don't know how to size a pointer type. I think that's the problem. Right. Now the preprocess is failing. Whoops. Oh well. Okay, so let's get this thing running and see if it crashes the GPU. Right, who's got their faith in me? Let's run a quick poll. GPU crash or the GPU crash? And by crashing, I mean it's going to destroy the stream. Let's do a minute on that one. Yeah, let's go. We've all seen it now, so will it crash? Pretty 50-50 right now. That's one, PS faith. Yeah. 4 people have faith, 3 people no faith. It's alright. We got this. No. Yeah. Well, you've been here campaign. We've had some meltdowns where it's just completely, kept crashing. There's sometimes where it crashed like 4 times in a stream before. Happened a few times. So silly. Right. We've lent over into the sort of like people have faith in what we've just seen. That's good. So we're only doing LOD 0, right? It's nothing complicated, but it could still crash. And we've got safeguards, right? Right, we all saw the safeguards. Alright, here we go. Alright, it runs. So, there it is. Here's our boy. So now we'll look at the data. So we built a render doc. Wait a minute, I gotta use my own special version because I've not bothered to get the latest build of the patch. But anyway, that's why I barely got on this computer other than streaming, so that's the way it is. Family life. So it did a capture, first frame. Ought to be good enough. So where's the bugger? Oh, is that a 0? Ugh, that's dispatch indirect, that's horrible. Right, be somewhere up here. It's that one probably, the 1 by 1 by 1. Looking kinda like what I want. Yeah, exactly. Come back. Yeah. It's a right pain as well because I want to. The worst thing is I have this like VOD channel, or I put the VODs right. For those who are interested, and sometimes when the stream cuts out, if I'm more than a minute of rebooting my PC, the Twitch is like okay, and it just cuts the stream there, and the VODs are split into 2. And I can't be bothered to obviously edit those. For good reasons. Oh, there it is, the compute pipeline. Right, alloc. No, this is not the one we're talking about. What about this one? Here it is. Here's our boy. So, if we go into the pipeline state, right, which one was it again? We'll look at the constructor nodes, right? We'll look at the spheres, we can look at the nodes. Right. Thank you, thank you. Well, except for these ones, we're on like, LOD and clusters part 9. That's as many, that's quite a lot, right? But I don't know what else I can name it. But yeah, I typically try and name them the best I can. Uh, it's quite hard. So this is all uninitialized memory, right? It might be best just to zero it to begin with. But I don't know. Okay, so they're kind of looking like fives, mostly fives in a way. But we obviously didn't put data here. Where do we put the data? So the way we've got this big old like block of memory, and that's where all the nodes go. Have I drawn this in the past? Here we go. Big old block of memory where there's just absolutely tons of nodes that go in here, tons and tons and tons. But we put our midpoint cursor here, slightly to the right, because there's actually more leaf nodes than there is non-leaf nodes, right? Just think about like a MIP texture. The highest MIP has more pixels, right? So it's a bit like that. So when you have this, right? So we've got to find where this midpoint cursor is, and then this is where our node would be, like right here next to it. Yeah. So we're just gonna. So what we can do, the first thing we're gonna do is get a new super lovely structure information. So write some. I don't know what this is, but we're just gonna say this is a volume cluster node, and we should. I'll copy and paste. I'll copy this just in case it likes to be a problem. Okay, we'll just do 4 U32s for now. Or should we? Yeah, let's do 4 U32s. Lock parent node index. It might not like the word U32. Sphere array or spheres array, and then children bit set. So let's copy that just in case. Right, it doesn't like U32, as I thought. So I want to do UN? Oh, it's got the multi-line. Oh. Oh no, it didn't. Kind of multi-line delete, but not edit. Alright, and away we go. So now we've got to find the offset. So what's the offset again? Byte range start. Row offset. Oh, we've seen a row offset. Okay. So given... Where have I put the spheres at? Non-leafs. No leaves. It's this number here. Now, yeah, we kind of want to go up to power of 2s again, to be honest. I need to rejigger these. Yeah, I need to we'll work these numbers. We'll do that in just a minute. Let's just debug this first one. We'll do 125. Right, things really start to change here. That's different, isn't it? So the parent node has been set to hang on a minute. What even is that parent node index? Shouldn't it be assigned 32? So what am I setting that thing to? What? That's the BVH code, not talking BVHs. Right, so cluster... Okay, so we need to set it to 0. 0 will mean... 0 mean invalid, point to self, right? Ooh, I'm starting to see things. Is this in the refined code? Yeah, the refine. So when we simplify. So we're saying if it's non-zero, so we have a parent. That's kind of nice. Oh no, it's not actually. I just realized they're not relative indices. They're from the midpoint. What's the way where we can guarantee it's an invalid index? Then maybe S32 max is probably alright. Okay, I got some things to patch. That's alright. Let's make persistent. Okay, so looking good there. There's that thing where I said like point to self. All that stuff was done today. Let's put an S32 max there instead. Huh. Right, so the problem is that buffer's now zeroed. Like... So when you allocate a new... there's a way to fill a buffer though. I've got to fill buffer 1. No. Memset E32. So I can specifically put a word in there, so I can do S32 max, and that'll clear all those child indices to an invalid state. So that's fine. Alright, so I'm glad I fixed that now. Well, thank you so much for the raid there, appreciate it. Welcome, Matim Menti. Thank you so much for the raid, sir. How's it going? Welcome, raiders. We're currently working on a very complicated sort of set of shaders for this game with an engine. We're currently building a volume of spheres, and we're building an LOD cluster system for those. I think we're going back to square numbers, to be honest, because that's a bit pain in the butt. Going back to square numbers. Oh, excellent. So yeah, it's 256 cubed volume, and that's what we are currently trying to get to work. This is we're currently just trying to build an initial volume, effectively. But yeah, any questions? Feel free to ask away. I hope the stream went well there, Matsumi. Okay, so now we're debugging the memory. Looking at the node, that was set to U32 max. That's what it was set to in the shader. So we did get to the right place. Then we've got So are these all 0? Yeah, LOD 0, offset 0, 0, 0. That makes sense for the location. So this has got already changed to a assigned int. Just overwrite that. There we go. So this next one is the spheres array. So I think this is, if we change this to hexadecimal. I don't know how you view it as hex. Oh, you bugger. But yeah, the idea is, I think in the spheres array, we're set it to invalid. No, maybe we're not. Okay, so we look at the start of the spheres. It must have put 4 spheres down. I can't quite see. Right, let's research on how to use RenderDoc. RenderDoc, most is really nice, thank you. Awesome. Buffer format hex. Right, you got these annotations. So we might be able to do something like this. Oh yeah. C 9. What? Right, so your start index would be right, all bits on. Invalid. Oh. So did nothing get placed down? See, I feel like we actually landed. So we, it's better off. We're better off probably like debugging, using print statements, to be honest, than doing it this. Maybe doing it this way. Well, we probably should do it both. Do both. Whatever's easiest for the problem. But yeah, so this seems a bit weird to me. Like that seems like all the low bits. Sorry. Oh no. Yeah, this is it means we didn't put any spheres down. Yeah, this is the default cleared value. So we didn't even reach here, which is where we expected to, right? So we can just print this out, right? So we just do this. And let's see what value we get back. So we're not even reaching in there at all. So all shaders, sorry, all threads not even getting there. Boom. So let's see if we get any booms. We got some booms. A bunch of bars and some booms. So we should have 8 booms, right? Yeah. So let's keep going. So what about here? Let's get some booms. Got some booms. So but what is that edits count? I could have swore that. Okay, I guess it's a 1. Who do you go into here then, right? So we unpack, and then you should get to here, right? Just a simple for loop. What is the problem? So we got some edits. So why was there no outside shape then? Was I just not reading? Was I not reading it properly? Okay, it did show up. Okay, so all of them but 1 got outside the shape. Anyway, so they keep going, and they'll paint down this fish. So should we see what spheres we got in the end? So let's print out this. Right, they're all going to print out the same number because it's in LDS memory. We got 1 sphere apparently. 1 sphere got placed down. Something's a bit fishy. Yeah, let's just go back up to here. So there's a few things that are a little bit weird. Like why? Oh, why? Is... So should we remove the rotation and just see if it's anything to do with that, which is messing things up? Then we'll pump in all the values. No, so don't do the rotation, it should be 0, right? So what I want to print out is essentially this coordinate. How are we going to do this? So the coordinate highest LOD, let's just print out some of this stuff. Let's print out all the data we need really and just see where it goes wrong. Then probably the rotated coordinate. Then probably the half dims. So let's just roll with that and see what we see what we get. Oh boy, I was hoping to get some sort of course, they're all ran, okay. There's my sort of CPU brain trying to program, and then you realize that they're all ran together at the same time. Derp. Okay, so coordinate highest LOD, this makes sense, right? There should be 0, 128, because you've got your highest level of detail, which is only a 2x2x2 spheres. So when that's in the highest level of detail, which is 256 cubed, the center coordinate is 128, right? That's all makes sense. Now, your rotated coordinate is, we're trying to land, what are we trying to do? Exactly. We're trying to take that and offset by 62.5. Sorry, 64, that's what I meant. What was I saying? That's in the old way. Yes, you add 64, so you put it in the middle of the cell. That makes sense. That's all good. Now the half dims is 126. What? 0.5? What the crap is going on here? Right, so clearly this is a little bit wrong. So can I just hardcode this to 128 and see if it adds so my unpacking for the fixed point stuff is kind of a bit messed up. But what I want to see, right, is if this gets all of them. No, so that side shape for the first one still fails, even though it's 128. There's still other problems. So let's look at that packing and see what the crap is going on, right? So we put half dim. Right, this should just be 64. Yes, the middle of the it's not the middle, is it? Let's make this a little bit smaller. Let's do like 40 or something like that. I think this is 104. Then it's covering all of them for some reason. Okay, something's clearly wrong with this packing stuff and unpacking. So to pack, we're flooring it, shifting it left by 6. Floor converts it in, shift left by 6. Or that, we've fract, so it gets the fractional part, times by 64, which is 1 shift left 6, right? Oh yeah. So you times that number by 64, then you're ANDing it with with 3F. So that's all the bits that come before it, right? 3F. So you're keeping all those little bits. You could probably floor it at that point. Well, it's floored, it'll truncate anyway. Okay, so unpacking. is shift right 6. Right, to convert that to a float, right? Plus, could my casting be a bit off? Yes, that'd be, seems to make sense to me. Could it be the casting that's a bit off? I don't know if that's true. It still says 104 on the half dims. Oh, we did modify the half dims. Alright, so maybe it is fine actually, thinking about it. Because we're adding this number, which is 64. So you've added 64 to it or whatever. Right, take 64 and that's 40. Excellent. Okay, so that is fine. So looking at these numbers then, why is it setting all of those on within the cell? It's saying your half dims is so the point is when you take your 2 by 2 by 2, let's draw this. Each one of these gets a sphere in it. Ta-da! But my edit, so this sort of ellipsoid that we're saying, hey, we're painting down here, goes here, and it's 40 in size. This is not drawn to scale, by the way. This is this has a width, height, it's square, right, or cube. This is 128, right? So this is 40 in size. When you add, so half of this is obviously 64, right? So you're adding half, right? Makes it 104. That's still within. Only so it should only put a sphere down in this grid cell. And that's 2 layers too. No, I'm using just C. Just C. No CPP. Right. So we add. So there's something wrong with the. It's either the way I'm doing this sort of like adding, or there's something wrong with the actual point in ellipse code. Let's double check the outputs we got. So this is in the center of the cell, right? 64, which makes sense. So this is the only one that should be on right now. This one here. So we'll look at the half dims is 104. Oh, are we adding way too much? Is it a quarter? Do you need to add a quarter instead? Do you need to add a quarter dims, or is it? You're adding 64. Yeah, if you offset by 64, maybe you need to add quarter dims. Yes, if you offset by half, then add half. No, 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 no. So I'm putting it in the center and I'm adding half. Yeah, half would get me, if I just have a point here and I increased it by the half, and I check if it's that this point is inside the thing I've just made, it'd be like, yeah, of course it is, right? So I need to add a quarter, and this will make it seem like, is that right? And if I add a quarter, right? Um, oh, no, 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 no. Wait, sure this is fine. No, adding half is probably, it should be. Yeah, 104. So there's 104 at here, which wouldn't even go outside any of these 128s, right? That's the idea. So I've increased the size of the shape. So I've increased the size of the shape by half of the cell, and we're sampling from the center of this place. Yeah, so I feel like this point in whatever is wrong. That's the sample point. Uh, should we just do a bounding box and let's see, or a keyboard, and see if that works. Let's see how many are in the. Right now the first one doesn't collide, but the rest do. Oh shit! I'm reading the boolean the wrong way around. Damn it. One means we're outside the shape, so we're going to skip. Zero means right, we hit. Perfect. So this one's fine. So that's exactly the behavior that we want. But what about this one? So we should expect a zero here. We're not getting it. But we've got it for the cube. The cuboid. So why then? Why is it not working? Because you're getting. We didn't look at center position, but I'll do that. Should just be zeros. Right, all zeros. Good, good, good. So half dims of this, and your coordinate is here. So it's basically saying given, right, this with a radius of that. So you'll get a sphere with this radius basically because they're all the same. It's not an ellipsoid in that sense. And you're at 64, 64. That should definitely be encompassed within there. So something's wrong with this point in ellipse code. So let me just Google for one. Um, Check if point is in ellipse. There's a really clever one basically, and that's what I copied in the past. Is this the formula? X take H. Then you square it, right? Yeah, so that gets rid of any negatives anyway. Divided by a squared and b squared. That's the radius. Oh, less than or equal to. Not that. It's floating point. It's not gonna be right. You sum them all up. They already use PAL to do that. So HK is a center position. AB and then XY up there. What's my HK? I don't think it matters so much. So the sample point. Yeah, that's right. So we subtract, then square the result. Works all good. Then it's radius. Then square the radius. Divide this by that. And you sum up the elements. Pretty legit. I don't know what the issue is then. It's a sphere though. It could actually be outside. What is the way we can check this is we just do a length op, right? So, so you do a length op on the on this, right? So then half dims. Right, but it'd be more. Would that be right? So I guess let's move the coordinate back to 0 and let's just see what happens. But it's super weird. Maybe we can... So maybe let's like not bother with the sort of add that we do here. Right. And let's just see what happens. Okay, so apparently we did. We are inside the shape at this point on that lower one, but why? So let's change the amount that we're actually adding. So we added, that's 64 there. Let's add 32, see what happens. That's still inside the shape apparently. Let's do 56. 64 is a problem. The 64 becomes a problem. Yeah, 64 doesn't want to work. So about 63. No, it doesn't work. About 60. So are they not the A and B here? They must be axis A and B both aligned. I have a feeling that A and B are the whole sort of length. The what's the way you call it? So you got the radius and you got the diameter, isn't it? I always think circumference for some reason. So it might be the diameter. Can we verify that? So the numbers that we had is 60. Right, when your half dims is 104. So half of 104 is 52, right? Quick maths. And there was an easy way to figure that out. You would align it. Problem is it's going diagonal. So what I need to do to verify this is let's not do it diagonal. So we'll just do it across the x. So 0, 0, right? So we just do it on the x, and we just go, we're just going to add. So let's add 51. And that should be inside still, right? Okay, so we're inside the shape. We've got 0 there. So but then if we go to 53, we should be outside the shape. No. Okay. Because I was thinking it's the half. Because it's just an ellipse, right? Right, should we go up to 64 and does that have a problem? 64 is fine here. So 64 across, right? So let's just keep going. Can we go to 90? Okay, 90 is fine. So if we can go all the way to 104 then, the ellipse function is probably correct. It's just, it was hard to sort of visualize it because it's 3D, right? So we go to 103. That's fine, we're in. Now let's do 105. And that should be outside. And if so, it's all good. Right, we're outside. Excellent. Seems like the ellipse function is fine. Tested at the cuboid one, it seems alright. So this means this code is probably all good. So if we position, so we just want to color in like one area, I think. What might be nice is if we center it. Yes, I think we'll keep these guys around. They're going to be useful. They really are. But what I want to do is, I actually want to move the center point. Probably in the middle of, so if I do 64, if I put it at 64, that's in the middle of the lower left, near sphere at the lowest level of detail. And then if we make it like 40 or something like that, as we increase the level of details, we'll see this sort of sphere get higher and higher LOD, right? So that'll just be a good one just to test out. It's just a sphere on one of the LODs. So that'll still work, right? There you go, got 0 there. Excellent. So let's go ahead and go even further. So we should be doing an add, right? Is new. We've got one is new, which makes sense, right? There's only one part of the the cluster's spheres that's actually getting there. So should I quickly just try all of them? Well, no, we can toggle between all of them. Let's just quickly see how this works down here. Like, do we get here? Do we get any spheres? We should only get one. Alright, we've got one sphere. Boom. So let's get 8 spheres. Let's double check that. So to do that, we're just going to put it in the middle. And this will affect all of them. So we should get 8, right? And we got 0. Amazing. Why, oh why? So it seems like that adding half is perfect for a box. But probably not for an ellipse. So basically we're trying to cheese out and do an ellipse versus box collision, but just sort of mess around with these guys. So it's great for this thing. But for the ellipse, it's just not gelling. So what's a way that we could... I want to do like an ellipse versus box, but I'm trying to like do it very simply, right? I'm trying to say like, you know, like given this center point and that center point, how can we do this quickly? So the way I was doing it is like, hey, I've got this half size. Increase this radius across X, Y, and Z by half, by this sort of half here. And then just check if this point is within this new shape that's been made, right? That's all we're doing. But I think we have problems around. So right now we've got the shape here. It's like a sphere. It's probably about 40 or something, right? And we're saying, hey, increase your radius along that way by half. So probably get it to about here-ish. And increase this one by half, probably get to about here-ish, whatever, right? Now when you draw a sphere, it might just miss it, right? So I think we've got to do something where we don't do a half. We do a little bit more. But then I don't know if we'll, like for these, like, because we're definitely inside it here. But I don't know if these are gonna, the ones that are sort of directly on the axes, these guys are gonna be able to sort of poke further than they should. Um, um, hmm. Yeah, so I wonder there's something amiss in here. I wonder what that could be, to be fair. Could it be, um, hmm. So I wonder. I wonder is anything to do with. Hmm. No. Yeah. Hmm. No, I'm not sure what the issue is actually, to be fair. Because if you got this and you sort of sweep it around and make a sphere out of that, it's larger than a you know, it's larger than a box anyway, right? Yeah, but that's the diagonal. What I'm talking about is this. Ah, I see. I know the problem. So I got this. Right, I make a sphere of that. Guess what? Your corners aren't going as far. So what you want is the diagonal. Is that right? So in case of the, you want to increase, so when you do the cuboid, you want to do that. Whereas when you do the, um, when you do the ellipsoid, what you kind of want is what's the way of doing it? So you've got this to here. And you have this edge as well, but you want that edge, so it's basically trig, isn't it? But equally, that's just a length hop, right? So it's that. Yeah, so what you want to do is actually add, like, you want to do length this, and then splat it across 3 into a vector, right? Something like that. And that'll do it. So that's triggering all of them right now. Right, so we get 8 spheres. But did we go too far? Right. There's no way to really tell that. Actually there is. So did we go too far? This should only be the bottom. Excellent, this should only be the bottom left. We put it back to that lower left corner where we've got our sphere down in the lower left corner. The thing that we're painting down here, and we're seeing if it, and it only affects this one obviously, right? Okay. That's good. Right, so I think that's a good place to put a pin in it. So that's L0, done for this shader. We've obviously done the reading through and seen that doing L1 and beyond should just work, but I think we just got to put a pin in it there because it's getting quite late now. So in the next stream, we're going to go down the LODs and just basically fill up the just make sure it all seems good, the values seem okay. Then and that's probably what we'll be doing on Sunday's stream. Yeah, and then probably should we do another edit as well? I'm not sure. Or maybe do a couple of edits. I don't know. Maybe just do the one. But the thing we want to try and do, a good one to get would be this occupation map, because we'll be able to view this in RenderDoc and literally just analyze how the thing actually looks. How the clusters, full sets of clusters look. But yeah, yeah, I think we really just want to test out the code and make sure it all seems legit. So yeah, next stream we'll basically ace this guy, and we'll carry on from there after that. Right, let's find someone to raid. I'll shoot this code up to the internet after the stream. Oh, glorious sir, it's been a while. How you been? Thank you so much, sir. Appreciate it. 8 months, look at that. Long story short, Your life was eaten by MMO. Awesome. Awesome. Doing well. Doing well. We've just been doing doing this LOD thing. It's been quite long. We've been trying to figure out good night, Jam on Toast. Good to see you. Thank you for coming by, my friend. Have a good night and good start to your weekend. So we've been doing this, where is it, the documentation. So we're doing this big old documentation of how we're going to do fully scalable scenes with tons of spheres and, blowing people's socks off and all that stuff, right? But so then so we did this plan the first stream or two, and then after that in the LOD stuff, we've been doing basically sketching out a whole bunch of shaders, data structures. So we've got whole tons of these data structures here to do with 3D volumes. How we're going to do that? We've been sketching out stuff, changing it, sketching out more stuff, changing it. But we've got it all sketched out now, and we're plugging it in one by one. So it's just a case of just making sure it all the code is correct, basically. So we've got these mega big shaders that we're just going to be trying to get running. So we're in that sort of moment right now, but it's all good. Things seem possible, and it's going to be amazing when it's all plugged in. But that's about it. But it sounds like you've had a good time off work. That's for sure. But yeah, I've got a jam though. I wish I could stay though. But thank you so much for the sub there, Clarissa. Yeah, it's pretty sweet. I'm looking forward to getting it all plugged in. There's still a ton of work that's got to go into it afterwards. So we'll do defrag, our own sort of custom allocator for the nodes, and defrag while the game's running. When you sort of destroy volumes and load new volumes in, you got fragmentation on the heap. But it's all good stuff and a lot of fun. So no problem with that. It's interesting that people have 48 views, and it's random projects. Interesting. Just doing multiple random projects at once. Must be. Alright, so what are we looking for? GBA. Let's read this dude. Alright. Okay. Have a good start to your weekend, everyone. I'll see you all on Sunday. Yeah, thank you for popping by. And right, catch you all in the future one. Catch you later.